Hello everybody, my name is Soborno from Very Science Lab, and I used to think twice before saying Saudi Arabia. In fact, people used to think twice before saying the Middle East. They were like, will they let me into airports now? So, however, now Saudi Arabia, that nation which was once feared, is now buying all the football players. At least it's going in the right direction. Okay, but we're not here for football news. Instead, we're here for some calculus.
By the way, who discovered calculus?
Fine, I'll answer that question for you.
Was it Newton or Leibniz?
Now, do not call me Leibnizist, but I believe that it depends on how many people showed up to each funeral. Okay.
The calculus discovered by the person who
had more people at their funeral. Desire? I'm not even gonna say it.
Plus times minus is plus. Isn't it racist?
Look, 8 brain cells. Let's put it this way. This is one line.
You just said I have 9 brain cells.
I'm going to teach you like the pundit in the first chapter of Manis. Minus plus minus is?
2 minus.
Yeah. How many lines are in 1 minus?
1 line.
So, that means that 1 line plus 1 line is 2 lines. How many lines are in a plus sign?
4 lines.
We are going to be integrating 1 minus 3y over the square root of 2y minus 3y squared dy. Okay, so what we have to do here is we have to u-sub. And in this case, 2y minus 3y squared without the square root is our u. U equals 2y minus 3y squared. So, taking the derivative, du is equal to, because this is to the power of 1, it gets eliminated and only the coefficient remains. And then, since this is to the power of 2, the power of 2 gets multiplied over here. 3 times 2 is 6. And then the power decreases to a 1. But you don't see a 1. So, du equals 2 minus 6y. So now, dy, because we're taking the derivative of y. So now, what we do is we solve for dy, and it's probably pretty obvious how you do that. The du over 2 minus 6y. As a shortcut, you can always just say that d times whatever variable you have is currently up there is equal to du over the derivative of your u. So, in this case, the derivative of our u is, of course, 2 minus 6y. So, we plug that back in. And this becomes the integral of 1 minus 3y over the square root of 2y minus 3y squared times du. Oh yeah, and sorry, but I forgot that 2y minus 3y squared is our u, so we just express it as u instead of the whole thing, times du over 2 minus 6y, the expression that we solved for earlier and we plugged in. So now you might notice that 2 minus 6y is simply 1 minus 3y multiplied by a factor of 2. So this is 1 minus 3y over the square root of u. If you wanted to, you could bring this up as u to the minus 1/2, which is what we will do in a second, times du over 2 times 1 minus 3y. Canceling these two out, we get the integral of 1 over 2 square root u du, which becomes the integral of 1/2 u to the minus 1/2 du. Now we use our reverse power rule where we add 1 to the exponent and then divide by that exponent. So 1/2 u to the 1/2 over 1/2 becomes what? Well, these 1/2 cancel out, just becomes u to the 1/2 or the square root of u, and plus c, and then we unsub, so our answer becomes the square root of 2y minus 3y squared plus c. We're going to be doing the integral of 1 over 3 times 2x minus 1 whole squared times, or rather just dx. Or if you wanted to, you could also put the dx on top and it has the same meaning, but it's harder to understand. So, now what can we do here? Well, this is pretty benign because it only has a power of 2, so if we wanted to, we could easily distribute it. But we can also U-sub, because the thing is, the 2x minus 1 inside these parentheses, the derivative of that is a constant. So, if we just treat this whole thing like a variable, it gives us a convenience and it doesn't really change anything. Do you want to see what I mean? Well, let's go. We U-sub, this is our u is 2x minus 1, and if you take the shortcut that I suggested in the last one, go watch problem number 5, then you'll notice that dx is equal to du over, what is the derivative here? Well, constants go to 0, this is x to the 1, so the 1 goes here, so it's nothing, and this is x to the 0 now. So this becomes 1. So that is du over 2. Alright. So now we plug this in and we get the integral of 1 over 3 times 2x minus 1 squared, or rather, in our case, u squared, because we're treating it like one variable, no longer need to put parentheses, times du over 2. So this is simply the integral of, we can actually bring this up, 1 over 6 u to the minus 2 du. Now we use our reverse power rule where we add 1 to the exponent and then divide by it. So this becomes 1 over 6 u to the minus 1 over minus 1 du plus c. Alright, so that becomes minus 1 over 6 because this is u to the minus 1. We can nicely plot that on the bottom. And that's it. Thank you. Oh, wait. I forgot the u is not a variable. So now we unsub and our true answer is minus 1 over 6 times 2x minus 1, or if you really wanted to simplify it, 12x minus 6 plus c. So here we would normally U-sub, but the integral is, the variable is already u. So instead, we'll V-sub. So this is going to be our v, and what we're going to do is we're going to take v, which is 1 plus 3u, and then, of course, we take the derivative, so dv is equal to, well, constants go to 0 when taking the derivative, then you remove the coefficient. You just take the coefficient if you're differentiating a coefficient times something to the power of 1. Alright, so dv is just 3 du. So now what we're going to do is we're going to solve for du, and that is dv over 3. Now, of course, we treat v like a regular variable. Subbing v in, we get the integral of 2 over v, and then dv over 3. So that becomes the integral of 2 over 3, and we can actually bring this v up, v to the minus 1 dv. Alright, and now we use our reverse power rule. But wait a dang second. What happens if we try to use our reverse power rule here? Doing x to the n plus 1 over n plus 1 rule, we get v to the minus 1 plus 1 over minus 1 plus 1, which doesn't work. So what do we do instead? Well, do you remember how the derivative of ln of x was 1 over x? Well, that is also x to the minus 1. So naturally, the integral of x to the minus 1 is just ln x. Alright, so that means that in this case, they're taking the constant out. That becomes 2 over 3 times ln x, or rather v in this scenario, plus c. But the thing is, v is a polynomial. So unsubbing, we get 2 over 3 ln of 1 plus 3u plus c. So we're going to integrate t over the square root of 2t squared minus 1. And we've got the drill. This is another u sub. This time, we're going to have to u sub 2t squared minus 1. And by the way, none of these really get hard until about number 30, so just wait for that. Okay, so this is u, and if you follow the trick that I suggested in the video for problem number 5, go watch it now. We can say that if this is u, 2t squared minus 1, we take the derivative. Well, what's the derivative here? It is, we do the power rule for t, and then constants go to 0. So, if this is the derivative, then dx, or rather, in this case, because we're integrating with t, dt is equal to du divided by this derivative for t. So now, this might seem bad since we have a variable here, but because it's on the opposite side of the variable over here, it's going to cancel out with that. So writing the next line, a little slightly bigger, we're going to have t over the square root of, don't forget this time, this stuff is u, and then we multiply that by du over 4t. So this is simply canceling out 1 over 4 root u du. And as we've seen before, this can be converted to 1 over 4 u to the minus half du. And now we use our inverse power rule. So we add 1 here and then divide by that power. So we have 1/4 u to the minus 1/2 plus 1 over minus 1/2 plus 1 plus c. So that becomes 1/4 times u to the 1/2, which is also known as the square root of u, over minus 1/2 plus 1 is 1/2. And dividing by 1/2 is essentially the same as multiplying by 2. So 1/4 root u times 2 is root u over 2. But then we have to unsub our u. So the result is the square root of 2t squared minus 1 over 2. Or if you want to write it this way, that's also fine. Plus c. We're going to be doing problem number 9. And we're finally free from the scourge of u-subbing. Well, I mean, this problem doesn't have u-subbing. The others definitely will. But at least this one is different because it's the integral of cosine 3x dx. Now, this one is actually a little tricky because of something I like to call the reverse chain rule, even though it's not actually a rule. So, you know the chain rule? Let's say, like, for example, we had tan of 5x. So, the chain rule here would say that first you take the derivative of the bare function, which is tan, so that becomes secant squared 5x, and then you had to take the derivative of the thing inside, so you multiplied it by 5. So now, can you think of any ways we can revert this to its original form? Well, obviously, the integral of this is going to become this, but we need to add a 1 over 5 here. Don't get what I mean? Well, taking the derivative of 1 over 5 tan 5x, on the other hand, would give you 1 over 5 times 5 tan 5x. So you kind of have to look out for this, because if you're taking an integral of some trigonometric function, then you probably want to put 1 over the derivative of what's inside that function before. So, first of all, let's just realize that the derivative of sine x is cos x, and the derivative of cos x is minus sine x. So that means that the integral of this is not going to be negative sine, but instead it's just going to be positive sine, because it's the reverse. And the integral of negative sine x is cosine x. Or in other words, the integral of sine x is negative cosine x. Okay, so that means that it should be sine 3x times the derivative of whatever inside. And the derivative of whatever's inside is 3. No, not times, 1 over it. So 1 over 3, 1/3 times sine 3 of x plus c is the answer. And just to test, if we take the derivative of this, then we can see that this c goes to 0, and this 3 gets carried over via the chain rule, so it reverts back to its original form, cosine 3x. That's the answer, 1 over 3 sine 3x plus c. Well, it's the integral of x over 1 plus 4x squared dx. And as you can probably guess, this is our u-sub, because taking the derivative of it, as you can see from just looking at it, will give us some coefficient times x, because it has the degree of 2, so taking the derivative of it will decrease that degree by 1. Alright, so u equals 1 plus 4x squared, thus using the trick that I mentioned while doing problem 5, go watch that video if you don't know, dx is equal to du over the derivative of this, which is, what is it? The derivative of a constant is 0 plus the derivative of this, utilizing the power rule, gives you 4 times 2 is 8, x to the 2 minus 1 is just x. So 0 plus 8x. dx is du over 8x. Alright, so thus that means that if we plug this back in, what do we get? We get the integral of x over our u times du over 8x, which becomes, after canceling out, the integral of 1 over 8, and we can actually bring this up, make it u to the minus 1 du. And as we know, we can't use the reverse power rule on this one, so instead we use the ln rule. This becomes 1 over 8 ln u plus c. And now we plug it in, giving us the final answer to number 10, which is 12.5% of the way through, or 1/8 of the way through. Fittingly, 1 over 8 ln of 1 plus 4x squared plus c. So the the funny thing is, this is the exact same problem, but without the x on the top, and yet it has a completely different answer. Yes, I know I haven't introduced this to you yet, but this is a mix of U-sub and trig. Wow, that's big. So, I'm going to just give you one hint in order to solve this problem. The derivative of arctan, or tan minus 1 of x, is equal to 1 over 1 plus x squared. Alright, let's see if you could solve it given that clue. 10, 9, 8, 7, 6, pause the video for more time, 4, 3, 2, 1. Alright, so you might have noticed this, but 4x squared is also the square of another polynomial. Not a polynomial, a monomial. Because, while it's not x squared, the square root of 4x squared is 2x. So the thing is, we can actually make u 2x. And that's necessary to reduce this 4x squared to just x squared, or rather u squared in this scenario. And the thing is, since let's use that trick we discovered on problem 5, dx equals du over the derivative of this is 2 by the power rule. And so, that means that it actually doesn't really affect anything. So, this is simply, let me write it a little bit bigger, the integral of 1 over 1 plus u squared times du over 2, which is really just du and then 1/2 tacked on outside the integral. So now you can probably tell that we can use that hint that I gave you to do the rest of this. So this is just tan minus 1 of our u plus c. So the answer is, let me just write it a bit bigger, not a bit bigger, a lot bigger, 1/2 tan, or let's just make it a little bit fancier, arctan 2x plus c. Exact same goddamn thing, but the bottom is squared. How cool is that? Fun fact, it's another u-sub. Okay, so u here this time is 1 plus 4x squared. You know the drill. Dx is du over the derivative of this. Go watch problem 5 if you don't get it. The derivative of this, constants go to 0. Power rule, 4x squared, you get 8x. So, oh yeah, I forgot to add the dx at the end here. So, you get x over u squared times du over 8x. This becomes 1 over 8 u to the minus 2 du. And now we just do our reverse power rule. And this becomes 1 over 8 u to the minus 1 over minus 1. So this becomes minus 1 over 8u. So it's minus 1 over 8 times 1 plus 4x squared. Usually they won't simplify it any further, but it's pretty easy to just distribute. What are we going to do today? Well, this is the exact same problem again, but this time it's a square root. Yay! But it's the exact same strategy, just that this comes out to u to the minus 1/2 instead. Oops, did I spoil the problem? Sorry. Go watch number 10. It's basically the same approach as this. If you don't get anything, this is our u. U equals 1 plus 4x squared. Dx equals du over 8x. Go watch problem number 5 if you don't get it. Lotta. And then we take x over the square root of u times du over 8x. Cancel. So it is the u, 1 over the square root of something, means that it's u to the minus 1/2. So doing the reverse power rule, this gives us u to the 1/2 over 1/2. And then that gives us the 2 root u plus c. Then we unsub u, and we get 2 times the square root 1 plus 4x squared plus c. That's it. Number 14. First of all, it's composite, but it's made of 2 primes. But 15 does that too, so it's not very special in that regard. And number 2, Augustus, the first Roman emperor, died in 14 AD. But no one cares. And number 3, in 1914, World War I started. All right. So now, let's begin. So here, this is actually the first problem that I got wrong. And what do we do here? Well, the thing is, you actually have to factor this. Because 4 minus y squared is equal to 4 times 1 minus y squared over 4. And also, fun fact, just like I think it was 12, this is another one of a trig integral coming out of nowhere. Why? Because it's going to say that the integral, or rather the derivative of arcsine of x is equal to 1 over 1 minus x squared. And hopefully you can figure out why that is true and why that helps us out here. Because the cheeky thing here, that y squared over 4 itself is simply the square of y over 2. Cheeky, man. Just cheeky. So, what you can do here is, this is 1 over the square root of 4 times the square root of 1 minus y over 2 squared. The thing is, you don't even need to U-sub for this one. So, obviously, this is 1 over 2 times, well, actually, maybe you do need to U-sub, now that I think about it. So let's just do it really quick. U equals y over 2. So that means that dx is du over 1 over 2, or rather 2 times du. If you don't understand this trick, go watch problem number 5 or 5 or 5, and it'll explain this. So dx is 2 times du. This is 1 minus u squared times 2 du. So cancel, cancel. We have the integral of 1 minus the square root of, oh god, I forgot the square root here. Square root of 1 minus u squared du. And that becomes, what was it again? Yeah, no, not tan. Arcsine, not x, u plus c. Now we unsub, and this gives us the answer, which is arcsine of the square root of, no, not the square root of y over 2 plus c. That means that if we take 1, 2, 3, 4, and 5 and arrange them in this triangle-like formation, the amount of circles here is 15. And the final thing, what does it share in common with 27? Well, 15 is composed of the numbers 1 and 5. If you add up all the numbers from 1 to 5, you get 15. Only 27 also shares this property. No other number to this day has been discovered that shares this. So I'll also celebrate when we get to 27, but enough about the yada yada mada mada. Let's start the problem. We have the integral of y over the square root of 4 minus y squared dy. This is another U-sub. I was just trying to make it less boring by talking about all these facts. So u is equal to 4 minus y squared, and so thus dx equals du over minus 2y. Go check out our video on problem number 5 if you want to learn how that works. So this is the integral of y over the square root of u times du over minus 2y. Wait, why did I write dx over here? And so these cancel out. We get minus 1/2 u du. Oh, this is u to the minus 1/2, by the way, because we're bringing it up, so it's negative. And then it's a square root, so it's 1/2. And then we use our reverse power rule, so this becomes minus 1/2 times u to the 1/2 over 1/2, because 1/2 is minus 1/2 plus 1. Okay, and that's plus c. So these two cancel out. We're left with minus u to the 1/2, or minus root u plus c. So unsumming, we get minus root 4 minus y squared plus c is actually 2 tetrated to the 2, which is really cool, because that means it's 2 to the 2 to the 2. This can also be expressed as like that. So, in fact, in both interpretations of this number, 2 to the 2 to the 2 and 2 to the 2 to the 2, they both give you the same results. Because this is 2 to the 4 and this is 4 to the 2, and they're equal. And also what's cool is that King Louis XVI, who was the last king before the French Revolution, remember how I said French people are not really people? Who was the last king before the French Revolution in 1792, he was King Louis XVI. And speaking of kings and queens, Marie Antoinette got executed
Why
too.
trans people are not people? Because they give up before the war starts?
They have wars with themselves at this point, because they can't deal with wars with others. Alright, so, oh yeah, they've gone through like 5 republics too. So, anyways, sorry French people, but the final thing is that, speaking of kings and queens being executed, chess is a game where each side has 16 pieces. Wow! 16 is a really cool number, don't you think? Alright, so let us do number 16. It's actually pretty simple. It's the integral of 2x plus 1 over 2x. And no, they're not some sort of sneaky U-sub that you have to do here. It's totally normal, right? You're right. Because this is simply just 2x over 2x plus 1 over 2x. Which is also just 1 plus 1/2 x to the minus 1 dx. And then just taking the integral of that, this, using the reverse power rule, becomes x, plus, using the ln rule, this becomes half ln x, plus c. Today, we're going to be doing number 17 of integrals. Alright, now 17 is a really cool number. It's probably the ultimate prime. You know why? Well, that's because it's a super prime. Not only that, but why is it a super prime? Well, because it's 2, 3, 5, 7, 11, 13, 17. It is the 1, 2, 3, 4, 5, 6, 7th prime, and it itself is a prime, and 7 is also a prime. Bungity dungity. So, it's a super prime, but it's also a twin prime. Just like 11 and 13, 17 and 19 only have one number in between them. Thus, they are called twin primes. It is also a Leyland prime. Think anyways, because I'm not sure if that's the name, but it's because it can be written as x to the y plus y to the x, and also x to the y minus y to the x. Don't believe me? Well, try 2 to the 3 plus 3 to the 2. 8 plus 9 is 17, buddy. Also, try 3 to the 4 minus 4 to the 3. 81 minus 64 is also 17. And not only that, but also it is a permutable prime, because any permutation of its digits either 17 or 71, both of them are prime. And also, it's Euler's lucky number. And also, it is the minimum amount of givens in a Sudoku puzzle for it to be solvable. Alright, so let's get to the problem. It's the integral of this, but it's unsolvable unless you distribute. So let's distribute. So, first of all, this is just x minus 2 times x minus 2 squared, which is x squared minus 4x plus 4. Then we can use the box method, which is my personal favorite, in order to multiply the rest. X squared minus 4x plus 4, and this is x minus 2. So this is x cubed minus 4x squared plus 4x minus 2x squared plus 8x, and then minus 8. So this is x cubed minus 6x squared plus 12x minus 8. And now you divide that by x squared. So this gives you the integral of x minus 6 plus 12x to the minus 1 minus 8x to the minus 2. So this is x squared over 2 minus 6x plus 12 ln x minus, now we have to use the reverse power rule. So this becomes plus 1, 8x to the minus 1 over minus 1. So these cancel out. This goes on the bottom, making the answer x squared over 2 minus 6x plus 12 ln x. Now once again, we'll do the special number routine, which is mentioning a list of special things about the number. First of all, the number is the only number in the entirety of existence such that the sum of the digits in base 10 is equal to half of the number, because 1 plus 8 is 9, which is times 2 is 18. Number 2, it is a semi-perfect number because the sum of its factors equals itself, namely 3, 6, and 9. The next semi-perfect number is also a perfect number, 28, and it is the second and only perfect number we'll see in this series. The first perfect number was number 8, and the third perfect number is 496. Euler discovered those, and 17 was Euler's lucky number. Okay, and number 3, well, are there really any other? Oh yeah, 18 is semi-prime because 2 times 9 is 18. Alright, so let us begin. So God, I feel like there's some fact that I'm not remembering. Okay, so let's begin. Oh, yeah. Just have to mention this one thing. Group 18 is, I believe, something that does not exist in the periodic table. I think 17 was the last one. I know, maybe I'm wrong. Okay, so, oh no, group 18 is the last one of the periodic table, and I believe those are the alkalines. I don't know, I can't remember my periodic table. It was a long time ago, I'm sorry. Not the same as 2-year-old me. Okay, get to the point. What are we doing today? Well, we're doing the integral of this root t minus 1 over root t whole squared dt. And now this is actually really easy. The book says to not distribute, but I'm going to distribute anyways. Distributing, we get a squared, so in this case t squared, minus 2 times a times b. So 2 times root t times 1 over root t. So that doesn't work because these cancel out. So t minus 2 and then plus b squared. So 1 over t becomes 1 over square root of t becomes 1 over t. So that's it. This just becomes t squared over 2 minus 2t plus ln t by the reverse power rule plus c. We're going to be doing number 19. Now 19 is also kind of like the sidekick of 17 in being the ultimate prime. Because while it's not a super prime, and it's not a permutable prime, because its only other permutation, 91, is, though it is semi-prime, it is not prime. It is still a lot of other cool things. For example, R19 is prime. What the hell is R19, you might ask? Well, that basically means if you take 19 ones, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, this number is prime. Also, 19, 109, and 1009, and 10009 are all prime. And 190 is the 19th triangular number. 19900 is the 199th triangular number, and 1999000 is also the 1999th triangular number. And 19 itself is actually a triangular number as well, as it is a central triangular number. That basically means that if you put one thing in the center here, then you put 3 more, maybe kind of like a soccer ball, modeling an equilateral triangle, eventually you will hit 19. I don't exactly know how central equilateral triangles, central triangular numbers work, but I'm assuming it's a diagram that looks something like this. So we have 4, and then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then I'm assuming that on the next one, 9 more dots are added. So, 19 is a really cool number. Oh yeah, and one more thing. You know how 91, the other permutation of 19? Well, 19 times 91 is the first Ramanujan number, or the first G.H. Hardy Ramanujan number. What does that mean? Well, that means it can be expressed as the sum of the cubes of 2 different numbers 2 different ways. It can be expressed as 1 cubed plus 12 cubed, which is 1 plus 17, 28. Or it can be expressed as 9 cubed plus 10 cubed, 729 plus 1000. Alright, so now enough of that blabber, but this problem is probably going to be shorter than the facts, because it's just powers of x. So we just have to reverse power rule this crap and we'll be fine. So this gives us 4x to the, well, adding 1 here is 4 over 3. Divide that by 4 over 3 is like multiplying by the reciprocal. And then minus 5x 3 halves, adding 1 to this, and that becomes 5 halves. So this is essentially 2/5 times 5x to the 5 halves. And then finally, minus x to the minus 1/2. You add 1 again, so 1/2, then multiply by the reciprocal, so 2x to the 1/2. That's it. But if you want to reduce, then we get 3x to the 4/3 minus 2x to the 5 halves minus 2x to the 1/2 plus c. So now let's do problem number 20 of integrals. Okay, so first of all, I just wanted to mention that I've only got one fact for this. I'm sorry. But 20 is not only the sum of a number and its square, namely 16 plus 4 is 20, but it is also a magic number in chemistry. What does that mean? Well, that means that atoms with this amount of electrons will be much more stable. So we've discovered most of the magic numbers, and the next one that might be in reach is 126. And there are no more magic numbers after that that are probable. 126, which I think is called unbihexium, is the possible next magic number. Alright, so now let's do number 20. It is the integral of x cubed plus x plus 1 over x squared. Now, what is the answer here? Well, this is simple. This is simply just x cubed over x squared is x. X over x squared is x to the minus 1. 1 over x squared is x to the minus 2. So, now we put dx and we're done. Well, now we have to take the integral. The integral of x is, as we know, x squared over 2. Integral of x to the minus 1 is ln x. X to the minus 2, we use our reverse power rule, and we realize that it's minus 1 over x. Over the square root of y times 1 minus the square root of y dy. Okay, so how do we differentiate this? Well, what you could do is this. You could distribute, but that doesn't lead you anywhere. Because if you distribute, which gives you the square root of y minus y, you can't do anything afterwards. Because 1 over the square root of y minus y is not equal to 1 over the square root of y minus 1 over y. Thus, the problem isn't solvable this way. Instead, we will have to U-sub. So, let u be 1 minus root y. Let's use the trick that we learned while doing problem 5 and say that dy is equal to du divided by the derivative of this, which constants go to 0 after derivatives, and this is minus root y, which is also minus y to the 1/2. So you take this, bring it over here, and then subtract 1. So it gives us minus 1 over 2 root y. Because of this minus, it goes on the bottom of the fraction. So that is equal to, well, see, because if you divide something by the reciprocal of another thing, that is equivalent to multiplying that thing by the other thing. Sorry if I didn't explain it that well. Hopefully this will be enough to understand what I just said. Okay, so using that rule, we know that we can simply bring this minus 2 root y up. We can get minus 2 root y du is equal to dy. Now, we plug this into our dy. And what do we get? Well, it cancels out this other y on the bottom. So, it gives us minus 2 root y over root y times u. These two cancel out, and we get du. And these two cancel out, and so we get minus 2 over u du, which can also be read as minus 2u to the minus 1 du. Since this is u to the minus 1, instead of using the inverse power rule, we will have to use the ln rule. We get minus 2 ln u plus c, which means that we get minus 2 times ln of 1 minus the square root of y plus c. 23 is a prime, and it is a concatenation of other primes. Basically, that means that both of its digits are prime. So basically that means it took 2 primes and smooshed them together. I think that the next number that does this is 2357, which is also prime. Wait, no, the next number that does this would obviously be 235. But still, whatever. Oh wait, no, the next number to do this would be 32. What? Sus. Let's get to the real stuff, which is actually really crazy because there are 2 coincidences here. So one of them is the birthday paradox, which says that if there are 23 people in the same room, then there is more than a 50% chance that 2 of them have the same birthday. Which seems very improbable because your birthday can be is 1 in 365, but it's true. And a similar related coincidence is that, look at this. There are 365 days in a year, right? Well, when we have 365, and if I remember correctly, you have to multiply it by the natural log of 2, then what do you think it gives you? Well, it gives you 252.999, very close to 253, which is the 22nd triangular number. And it is also the amount of unique pairs that can be made with 23 objects. So if you had 23 different fruits, then that's how many unique pairings you can make with those 23 fruits. Okay, so now let's begin. 23 is the integral of sine theta cosine theta d theta. Okay, so how will we do this? Well, this is another U-sub. So what we do is this time we'll let u be sine theta. You can also let u be cosine theta and it gives you the same answer. So then d theta is equal to du over the derivative of this, which is cos theta. If you don't get this trick, then go to problem 5. So that means that we can simply plug this back in. We get the integral of u cos theta times du over cos theta. Canceling these out and giving us the integral of u du, which using the reverse power rule, we've done this many times before, u squared over 2, which means that it's sine squared theta over 2 plus c. This is actually a 5 hemi-perfect number. What the hell does that mean? Well, it means this. 5 in hemi means 1/2. If you multiply 5/2 by 24, you get 60, which is the sum of all of its factors. 1, 2, 3, 4, 6, and then 8, I think, also factors into there. And then there's also 12, and yeah. The sum for all of this crap is 60, I believe anyways, right? 10, 14, 24, 36, oh yeah. Now it's 60. Okay. And also, it is a semi-perfect number because if you add up some of its factors, not all of them, if you add up these factors of 24, then you get 24 itself. Cool. Alright, so now let us begin. Oh yeah, and before I begin, 24 is also the amount of hours in a day. Okay, so right now we're going to integrate sine rad x or root x, calc teacher says rad x for some reason, over root x dx. Alright, so now this is actually another u sub. So u root x, go to problem 5 if you don't understand what I'm about to do next. Dx is equal to du over what is the derivative of this? This is x to the 1/2. Bring that down. Subtract 1. 1/2 x to the minus 1/2. Now dividing by a reciprocal, like multiplying what's under that reciprocal. So this is essentially equal to 2 root x times du. Okay, yada blada. And you can actually do something very illegal here. Because instead of labeling this as sine u over u, you can actually do something so illegal it scares me. You could do sine u over root x. You don't have to substitute u in for root x. So we get sine u over root x times 2 root x du. It's revolutionary. So it's 2 sine u du. And now, when doing that, you just get 2 minus 2 cos u plus c. Because the integral of sine is negative cos, that's why you get that extra minus sign at the end. Now we unsub, we get minus 2 cos root x plus c. This is our 5th perfect square, but it is also pretty cool because 1/4 is equal to 0.25. Oh, that's not special enough for you. Okay, I hear you. Wait, what else is special about this number? Not much. Okay. So, what are we going to do? Actually, now that I think about it, 25 can also be written really cool if you just take this 2 and then you shrink it so that it becomes like this, and then you just put it over here. That's another way to write 25. So, now, let's begin. What we're going to be integrating is t cos 2t squared. And yes, you're seeing that right. You can basically just call this 4t squared, dt. Alright, so what do we do? U-sub. You don't understand what I'm about to do? What's problem 5 is all I've got to tell you. dt is equal to du over at, because that's the derivative if you power rule it. So you just plug that in, plug and chug, get t cos 4t squared times du over at, cancel. Oh wait, no, this is supposed to be u. This is going to be 1 over 8 cos u du. Now integrating cos just gives you sine, because the derivative of sine is cos. So you get 1/8 sine, and we unsub u, so that's 4t squared plus 8. So, before we start, 27 is actually this number. Or if you want to look at it in a more conventional way, it's this number. What does that mean? Well, that means it's 3 to the power of 3, or 3 cubed. Sadly, this is the last tetration we will see, as 4 tetrated to the 2 is equal to 256. Alright, so For number 27, let us begin. So, what are we going to do? Well, we're going to take the integral of sine 2 theta d theta. And this is actually not what you expect, because there's no sort of chain rule here, because look at this. Sine of a plus b is equal to sine a cos b plus cos a sine b. And can you tell me what 2 theta is? Well, it's theta plus theta. 1 plus 1 is 2, theta plus theta is 2 theta. Simple maths, guys. So, if we're doing sine of theta plus theta, then we should get sine theta cos theta plus cos theta sine theta. But wait, these two are the same. So you could just write this as 2 sine theta cosine theta, or vice versa, 2 cos theta sine theta. And then we could solve it like how we've solved one of the almost identical problems we've had in the past. Because essentially all you have to do is take sine theta as u, then dx is du over cos theta, because that's the derivative of sine theta. If you don't understand what I'm doing, go to problem number 5. And now, oh wait, not dx, oopsies, d theta. And now we plug this thing in over here. We get the integral of 2u times cosine theta times du over cos theta. Cancel, cancel. We get the integral of 2u du, which is equal to 2 times u squared over 2 plus c. So these cancel out and just u squared plus c, highly convenient. Or in other words, it's simply sine squared theta plus c. Alright, but before we begin, I would like to say a few things. 28 is actually a happy number, it's triangular, it's hexagonal, and it's a magic number. What does all of that jibber jabber mean? Oh yeah, and it's a perfect number as well. What does all this jibber jabber mean? Well, a happy number means this. Take the sum of the squares of its digits. 2 squared plus 8 squared. What does that give you? 68. Now, take the sum of the squares of those digits. 6 squared plus 8 squared is 36 plus 64 is 100. 1 squared plus 0 squared plus 0 squared is simply 1. A happy number is a number such that if you add up the squares of the digits and then keep going, it will eventually reach 1. Something like 4 is not a happy number, by the way. So, triangular. What did that mean? Well, that means that if you add up the numbers 1, 2, 3, 4, 5, 6, and 7, you get 28. What does hexagonal number mean? Well, it means that if you basically take this small hexagon with 6 dots, then you expand on it, 1, 2, 3, and then you just expand the side lengths. Eventually, this dot sequence will reach 28 dots. A magic number is a term in chemistry that means that the atom with that number is very stable. Atomic number, sorry. The atom with that atomic number is very stable. And it is a perfect number because if you take the sum of all of the divisors except itself, then you get it. 1 is a divisor, 2 is a divisor, 4 is a divisor, 7 is a divisor, 14 is a divisor. What happens when you add them up? 3, 11, 14, 14 plus 14, 28. Alright, so now let's get going. So, how do we do taking the integral of x cosec dx? And now, I have to introduce you to integration by parts. So, it's exactly what you hear. It's integration, but by parts. Basically, it says that the integral of u dv is equal to uv minus the integral of v du. So what happens if you take the derivative of this entire equation? You get u dv is equal to, well, oh no, never mind. Okay, so this is the equation that we're going to use. The only thing you have to decide is what is u and what is dv. And the thing is, let's make this little table. Once you have u and once you have dv, you still don't know. Once you have u and once you have dv, you still don't know your v, and you still don't know your du. So, what we're going to do is we take our u, and this acronym, LIPET, usually helps with it. Whichever function comes first, and basically look at one of the two functions. Whichever type of function comes first up here will be u, and the other one will be dv. L stands for logarithmic. I stands for inverse trig. P stands for polynomial. E stands for exponential. And T stands for regular trig. Now, I would say that x is an exponential function. Well, actually, not really. You could say it's a monomial, but whatever. Trig is last, so it's going to always come up as dv. This is going to be u. Alright? Okay, let's move on with our lives. So, once we have u, we want to know du, because we need to do this integral. Now, that means that we have u is x and dv is cosec dx. Now, what we have to do is, we have to do an integral to get v, and we have to do a derivative in order to get du. So du is just going to be dx, and v, remember, it's just going to be sine x. No, we don't do the little constant this time. Okay, so now that means that the integral of x cosec dx is equal to uv, so u times v is x times sine x minus v du, sine x dx. And this is a much more doable integral, since by definition this is simply negative cosine x. So that means that the integral of x cosec dx is equal to x sine x minus, minus cosine x, and then since there was some integration going on, just put a plus c. So the answer is x sine x plus cosec plus c. There are only two actually interesting things about 29. One, 2 squared plus 3 squared plus 4 squared, believe it or not, is 29. And second, 29 is our 10th prime. Cosine squared 3u. Now this might look tricky, but think about it. Cosine squared 3u is really just the same as cosine 3u whole squared. And now, you see, this is essentially I guess you could say cosine 3u to the minus second power. And we all know cosine 3 to the minus first power, not to be confused with the arc cosine, even though I don't know if that actually exists. Not to be confused with it. But cosine x to the minus first power is secant x, because 1 over cos x is sec x. So we know that this is simply just sec 3u to the power of 2. And we know that the derivative of tan x is sec squared x. So sec squared 3u du, well, we kind of use what I like to call the reverse chain rule here. We take the derivative of this, make a reciprocal, and then put it on the outside. The reciprocal of the derivative of this is 1/3. So we get 1/3 times tan 3u plus c, 30 of integrals. Now, I just wanted to share with you one really cool thing about 30. 30 is a semi-perfect number because if you add up some of its divisors, then you get the number itself. 30 is also what's known as a Arctan number because it is divisible by the sum of its digits. And finally, 30 is a square pyramidal number. Do you know why? Well, basically, if you take one square and then a smaller square on top of it, then an even smaller square on top of it, then the smallest square, then if this square has a side length of 1, if this square has a side length of 2, if this square has a side length of 3, and if this square has a side length of 4, then their areas will add up to 30. That's right, 1 squared plus 2 squared plus 3 squared plus 4 squared is 30. The next number that has this property would be 55, and the previous number that had this property was 14. I don't believe there is a number that we will do after 55 that has this property. So sad. So let's do this. This appears to be a pretty easy U-sub looking at it on first glance. 1 plus sine x is going to be our u, and so u is equal to 1 plus sine x. Then I'm going to do this trick. You gotta watch problem 5 if you don't understand what I'm doing. What's the derivative of 1? Constants go to 0. The derivative of sine x is cos x. Okay, so this becomes the integral of cosine x over the square root of u, because u is 1 plus sine x, times du over cosine x, because I plugged in this thing for dx. Alright, so now these two cancel. We get the integral of 1 over root u du. Now we bring this upstairs, and the square root of something is u to the 1/2. So 1 over u to the 1/2 is u to the minus 1/2. Now we just reverse power rule it. We add 1 to the exponent, u to the minus 1/2 plus 1, and then divide by that new thing. And that's our answer. So minus 1/2 plus 1 is 1/2. And dividing by 1/2 is like multiplying by 2. And also, remember that u to the 1/2 is simply the square root of u. So, now we unsub u, which is 1 plus sine x, we get our answer. 2 times the square root of 1 plus sine x plus c. That's it. Before we begin, 31 is a pretty cool number because, and I just goddamn discovered this, the name for a backwards prime is an emerp. Because that's prime backwards. Like Jesus Christ. But did you know 31 backwards is 13, which is an emerp because it's a prime but backwards, but it's also a prime. 31 is also a permutable prime because its other permutation, 13, is a prime too. 31 is a happy number because if you take the squares of its digits and then keep going with the answer, for example, 9 plus 1 is 10, then eventually you will reach the answer 1. Bing bong. And finally, for all people who like computers, 2 to the 31 minus 1 is actually the 32-bit integer limit. Positive 32-bit integer limit. And also 31 is a Mersenne prime because it can be written as 2 to the 5 minus 1. And Mersenne primes are primes that can be written as 2 to the n minus 1. Probably pronouncing Mersenne wrong, but okay. So cosine theta minus 1 d theta over sine squared theta minus 1. What do we do here? Well, let's use some maybe. Probably. Let u be theta minus 1, and this isn't anything groundbreaking. Dx equals du over the derivative of this is just 1. Variable goes to 1, constant goes to 0. So this dx is literally just du. So what we're really doing here is the integral of cos u over sine squared u du. Now here's the dingo-me-mingo. This is equivalent to cosine u over sine u times 1 over sine u. That's pretty clever because now this can just be written as cotan u, and this can be written as cosecant u. You might notice that this has a resemblance to the derivative of secant x, which is tan x secant x. But it's with the co-versions instead. So, what can we do here? Well, now you may not know this, but the derivative of minus cosecant tan u cosec u. So, that means that the answer is minus cosecant u plus c, but wait, we gotta unsub. So the real answer is minus cosecant theta minus 1 plus c. Pretty cool number. Why? Well, 32 is not only, as I've said before, 2 to the 5, but also 32 is, wait, I just realized something. 32 is equal to 2 to the 3 plus 2. Anyways, 32 is also equal to, 32 is also actually equal to 2 to the 4 plus 4 to the 2. That's being a Leyland number. I think 17 was a Leyland number too, but I can't remember. And finally, even cooler, 32 is 1 to the 1 plus 2 to the 2 plus 3 to the 3 plus 4 to the 4. The next number, no, not plus 4 to the 4. The next number with this is 288, which is 1 to the 1 plus 2 to the 2 plus 3 to the 3 plus 4 to the 4. But that's what's even cooler, that 288 is also 1 to the 4 times 2 to the 3 times 3 to the 2 times 4 to the 1. And it's also equal to 1 factorial times 2 factorial times 3 factorial times 4 factorial. Jesus Christ, did he? Okay. Now let us get started. This is just one by definition. If you don't know, the integral of secant x is equal to ln of sec x plus tan x. So, I'm gonna do it, boys. Oh yeah, technically you have to U-sub, but it's not that much. U is t over 2. The derivative of this is 1, so dx is literally just du. So you're taking the integral of sec u du. So it's just equal to ln sec of u, which is t over 2, plus tan u, which is also t over 2. 3 is our smallest odd, as they call it, rep digit, which is basically a number with only one digit that repeats. It's the smallest odd rep digit that is not prime, because 22 is not odd and 11 is prime. 33 is divisible by the amount of primes below it, which is 11. The last number that shares this property is 30, which is divisible by 10. Alright, so now, oh yeah, and 33 is also kind of maybe part of an unsolved problem in mathematics, because it's the sum of 3 cubes. The numbers behind the cubes are like all 9 digits long, so I can't remember them all, but I can tell you that 2 of them are negative. So basically the problem is, if a number is not congruent to 4 mod 9 or 5 mod 9, then is there a number that is not congruent to 4 mod 9 or 5 mod 9 that is not expressible as the sum of 3 cubes? Here we have sine 2x. And the thing is, I think you might have seen this before, but we already know that sine of a plus b is sine a cos b plus cos a sine b. Now, can you tell me what 1 plus 1 is? Tell me.
2.
Okay, so what is 2? Can you express 2 using addition?
1 plus 1. Or sine 1 plus 1.
So now we can say sine 2x is just sine x plus x.
That's correct.
So that's sine x cos x plus cos x sine x. And using the amazing properties of the commutative property, this is actually sine x cosine x. So this is just 2 sine x cos x. Wow! So that means that we can rewrite this as the integral of 2 sine x cos x over the square root of 1 plus cos squared x. Now I think we all know what needs to be done now. We need to u sub. U is 1 plus cosine squared x, and you have to double chain rule for this differentiation. Well, not really, because the derivative of x is just 1. But still, look at this. So, du is actually going to be, let's work this out, derivative of constant is 0. Then we have cosine squared x. So, first of all, cosine squared. We need to take care of that, so we power rule it, put that 2 in the front. So we got 2 cosine x, and then the derivative of cosine x itself is sine x, and then you need to take the derivative, the little guy inside here, x, but that's just 1, so that doesn't count. So we get 2 cosine x sine x dx, so that means that dx is du over all this crap. And using the power of the commutative property, we can rewrite this as 2 sine x cos x. Do you see the likening now? I'm sure you do. So now, oh wait, oopsies. So now, we see that this is 2 sine x cos x over the square root of u times du over 2 sine x cos x. That's so cool. Cancel, mansel. And now, we all know how to express 1 over root u, right? That's u to the minus 1/2. And I'm sure we've done this integral many times before. It's just 2 root u, or 2u to the 1/2, if you want to be fancy about it, or u to the 1/2 over 1/2, if you want to be fancy about it, or u to the minus 1/2 plus 1 over minus 1/2 plus 1, if you want to be fancy about it. So, sorry for all the blabbering, but this is just 2 root u. What's u? 1 plus cosine squared x plus c. That's it. So, far as I'm aware, the only really thing that's really interesting about 34 is that not only is it surrounded by semi-primes, this is 11 by 3, this is 5 by 7, but it is a semi-prime itself. What's even cooler is that 33 has 4 factors. 1, 3, 11 itself. 35 has 4 factors. 1, 5, 7 itself. And 34 as well has 4 factors. 1, 2, 17 itself. Alrighto. So now let us begin. We've been trying to reach you about your car's extended warranty. So, what do we do here? Well, this is actually a quite easy problem because let's secant 3 halves x be u. And then I'm going to do something so legal here. The derivative of this is actually pretty tricky. Because when you take the derivative, here's what you get. You would first get the instinct to take the 3 halves out and then subtract the one, but then remember that the derivative of secant x itself is secant x tan x. And then you could take the derivative of x, but it's just 1. So du is literally just 3 halves, dx. 3 halves secant 3 halves x, tan x, dx. So now, doing the dividey, we get dx is du, 2/3 du times 1 over secant 3 halves x tan x, and that's it. Alright, so now, plugging all this crap in, what do we get? Well, we get, and as you can see, these two cancel out. We simply get, we take this over here, 2/3 du. Now, we didn't have to make anything u because you just use the constant rule here, and the answer is 2/3 u plus c. So it's 2/3 secant 3 halves x plus c. You know how a triangle is formed by putting these lines together? Well, a tetrahedron is formed by putting those kind of triangles together. Like 1, 3, I can't illustrate very well, but 35 is the number that occurs when you add the first 5 triangular numbers, which are 1, 3, 6, 10, and 16. Word. That actually kind of looked like the Fibonacci sequence. Wait, no, not 16, sorry, 15. Okay. And one other thing that I needed to mention, we've been trying to contact you about your car's extended warranty. So, tan theta d theta. How do we do this? Well, tan theta is simply just sine theta over cos theta. D theta. So now, we set u equals cos theta, thus dx equals du over minus sine theta. If you don't understand what I'm doing, go to problem 5. Du over minus sine theta. Now, wait, no, not dx, sorry. D theta, plug that in. We get sine theta over cos theta, or rather u, times du over minus sine theta, cancel, and we get negative 1 over u du. 1 over u is simply u to the minus 1 du. We use our ln rules. We get minus ln, what was u again? Cos theta. And fun fact, I just discovered this, minus ln x is actually equal to ln of 1 over x. So this is also equal to ln secant x. 3 plus 6 is 4. Wow, outstanding. So, also, the sum of 36 is a tri-square number. Why? Well, That's because try is squared. That's because 36
Something 36.
is equal to 6 squared, and 36 is also equal to, if I remember correctly, 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 0 plus 0 plus 0. Cool, right? Okay, so dx over sine squared 2x. Well, the thingo hero is that 1 over sine squared x can simply be written as cosecant squared x. So, what do we do here? Well, I guess we use up u is 2x, dx is du over 2. Watch problem 5 if you don't understand. So, we get the integral of du over 2 sine squared u. And I guess we could just bring that 2 outside. Alrightos. So now, yeah. 1/2 cosecant squared u du. And you may or may not have noticed that this looks similar to the derivative of tan x, which is secant squared x. Well, you got that one right, because this is simply just minus 1/2 cotan u. But, because the derivative of negative cotan u is actually cosecant squared u. Pretty cool, right? And now we unsub u, which is, where was it? 2x. That's the answer, plus c, because the derivative of tan minus 1y is 1 over 1 plus y squared. So now, doing this and dividing both sides by 1 over 1 plus y squared, we get dy equals du times 1 plus y squared. Now, we plug that into the original, u over 1 plus y squared times du times 1 plus y squared. Canceling out, we get the integral of u du. So we get u squared over 2 plus c. And tan minus 1, just to cause no confusion, we will write it as arctan. So the answer is arctan squared y over 2 plus c of integrals. Now, 38 is a cool number because, number 1, 37 and 38 are the first 2 consecutive numbers to both not be Harsad numbers, or both not be divisible by the sum of their digits. So, 38 factorial minus 1 is also prime. And this is the 16th prime that can be expressed as n factorial plus minus 1. Alright, so here we have sine 2 theta, cosine theta, d theta. How do we do this? Well, sine 2 theta, as we've seen before, is simply sine of theta plus theta. And we know that sine of a plus b is equal to sine a cos b plus sine b cos a. So applying that logic here, we have sine x cos x plus sine x cos x, or 2 sine x cos x. Or in this case, sine theta cos theta. Sorry. So now that means that we have 2 sine theta cos squared theta, d theta. And now what we need to do is u sub, u being cosine theta. And now, taking du, dx equals du over the derivative of cosine is minus sine theta. Don't understand what I'm doing? Go back to problem 5. Then we plug that in. Oh wait, no, not dx. Oopsies. We plug that back in. 2 sine theta cosine squared theta, or rather u squared, over minus sine theta du, cancel, we get minus 2u squared du. So now, taking the integral of this is minus 2 over 3u cubed, and u is cos theta, so cosine theta cubed plus c. Oh wait, no. First I gotta introduce some special facts about 39. First of all, 39 is actually the sum of 5 consecutive primes, and it's the product of the first and last of them. There are only 3 other small semi-primes that share this property. I forgot the last one, I'm sorry. And that's basically it for 39. Okay, so now let's erase the sad looking 39. Let's begin. So this is going to be our u. So if this is u, then using the chain rule, we can pretty easily deduce what du is going to be. Constant rule, constants go to 0. Then we use the chain rule and take the derivative of 2t. Bring that out, that's a 2. And the derivative of cosine is negative sine. So altogether, it gives us 2 sine 2t, and then dx. So now we divide both sides by this crap, and we get dx is du over 2 sine 2t. Wait, why am I using dx? Whoopsie daisies. Okay, so now we plug that in. And what do we get? Well, we get the integral of sine 2t over u times du over 2 sine 2t. Canceling them out, we are left with 1 over 2u, which can also be written as 1/2 u to the minus 1 if we choose to bring that up, du, and using the ln rule, this just becomes 1/2 ln, and we unsub u, which was 1 minus cos 2t. And then we always gotta add that plus c. Oh yeah, I forgot. 40 is actually written as a rep digit in ternary, which means that it's written like this. What does that mean? Well, ternary is base 3. So that means that 40 is 3 to the 3 plus 3 to the 2 plus 3 to the 1 plus 3 to the 0. Pretty cool, right? And it's also 3 to the 4 minus 1 over 2. Pretty cool, right? Alright. So here we have cotangent to u du. Now, first of all, cotangent at u is a pretty standard integral. You kind of want to memorize it, but you can just do it by hand as well. So, first of all, we want to take care of that 2u, so let v be 2u. Then, du is equal to dv over the derivative of this, which is just 2. And if you have no idea what I'm talking about, just know that the intermediate step is this. Hopefully that will explain it. Okay, so now that means that we essentially just have, we can take that 1/2 out, cotangent v, dv. So now, how do we solve this? Well, cotangent v can be broken down into cos v over sine v. And from there, it's a simple, what can I call this? W sub? T-U-V, W? Okay, yeah, W sub. So, let W be sine of v. I can't believe how real this is. And so, let's use that intermediate step again. dw is going to be the derivative of this, which is going to be cosine v, I think. Yeah, I think it's cosine v. And so that means that v is equal to dw over cos v. Now, plugging that in, we get 1/2 times the integral of cosine v over w times dw over cos v. Cancel, cancel. So we get half the integral of, bringing this up, this is w to the minus first power, dw, and then using the ln rule, it's just 1/2 ln of what's inside that package. W is sine v, and v is 2u, so w is sine 2u. That's it. Oh, wait, plus c. But it's actually called a safe prime. Why? Wait, no, it's not called a safe prime. It's called a Sophie Germain prime. Wonder how it got that name. Why? Because 2n plus 1, or in this case 2 times 41 plus 1, which is 83, is also prime. And this is a safe prime. And also, this is the last and biggest lucky number of Euler. What are Euler's lucky numbers? Well, they are numbers such that for a number n, 1 is less than k is less than, given that 1 is less than k is less than or equal to n, k squared minus k plus n for any value k yields a prime number. And yes, in this case, k squared minus k plus 41 for any number between 1 and 41 gives you a prime number. Let me pull something out of my hat as an example. 11, for example. 121 minus 11 plus 41. 151 is prim. All right, so now, let's get down to business. This is another U-sub. I think it's quite obvious what it is at this point. Sure, you could have guessed it was a U-sub. Let's just do it, man. du is equal to e to the x dx. Thus, dx is du over e to the x. We plug that straight in there. We get the integral e to the x over u times du over e to the x. Now, since this is on the bottom, we can rewrite this as u to the minus 1. And using the ln rule, we can say that it is ln u. But what is u? ex plus e to the x minus 1. Our second sphenic number. Our first was 30, but sadly I didn't announce it. Whoops. What does sphenic mean? Well, unlike twin primes, that means it's a multiplication of 3 prime numbers. 3 different prime numbers. So, now, 42 is also a pretty cool number. Just saying that. Alright. 42 is a Arcsin number because it is divisible by 6, which is the sum of its digits. 42 is also an abundant number because the sum of its factors, which is 1, 2, 3, I don't think 4 factors into it, 5, 6, 7, and then 14, and then I think that's it, yeah. The sum of its factors is way over 42. Well, at least I think so. Oh wait, no, I did it wrong. Whatever. I may have missed 1 or 2 factors, but it's fine. Oh yeah, plus 21. 19 plus 21 plus 14 is 54, which is definitely greater than 42. So it's an abundant number because it's lesser than the sum of its factors. It's also, can't think of anything else. Oh yeah, it's also a pronic number. Why? Because it can be expressed as n times n minus 1 or n squared minus n. In this case, n is 7. Alrightos. So now let's begin. Oh, x times x minus 2. That's pretty similar to n times n minus 1. So this one is really simple. First of all, you have to distribute. Then you gotta U-sub. And then through the steps, that we always take. Du is derivative dx. So thus dx is equal to du over 2x plus 2, which is actually 2 times x minus 1. So you have the integral of x minus 1 over u times du over 2 times x minus 1. Cancel, 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 cancel. That gets you, this is 1 over u, which can also be written as u to the minus 1. I just took this 1/2 out if you were confused. Then and using the ln rule, we get 1/2 ln u, and we unsub u, which is x squared minus 2x. Or the book strangely writes it as x times x minus 2. That's it. Oh, that's it. Problem number 43. Now 43 is a really cool number because it actually constitutes a twin prime with 41. And also it's a cousin prime, I believe, with 47 because it's 4-way. And also, there's actually a sequence, I believe, where you have n0 is 1, n1 is 1, and n to the x, I guess, is equal to 1 over n to the 1 n to the x minus 1 times n to the 0 squared plus n to the 1 squared, etc., plus n to the x minus 1 squared. Now, this sequence is cool because n to the 43 is actually the first non-integer in the sequence. Actually, now that I just realized that this is actually not represented with n, but rather a. So that's a whoopsies on my part. Okay. Do not make that face. Look like a cat. Okay. So now, here we have... Are you kidding me? It's another u sub. Du is equal to 2x dx. Thus, dx is du over 2x. Hopefully you can see that once I plug this in, these x's will cancel out and we'll just be left with the 1/2. So, we get 1/2 e to the, and I made u x squared because this x squared is on the top here. And now, we can just take this 1/2 out. And we all know the integral of e to the u du is simply e to the u, because the derivative of e to the x is just, say it with me, e to the x. So it just gives you 1/2 e to the u plus c. U is x squared. That's it. Thank you everybody for watching. 2 theta sine of e to the 2 theta. D theta. Now how do we solve this? Well, it's another u
solve it.
So u is equal to e2 theta. So, now let's differentiate. That means du is going to be, well, let's put this, take it down, 2e to the 2 theta d theta. So now, that means d theta is du over 2e to the 2 theta.
Isaac, can I
so
say
we have
something?
e to the 2 theta sine u times du over 2e to the 2 theta. We can actually take this 1/2 over here out, so that leaves us with 1/2 times the integral of, let's cancel these out, sine u du. And that would just be negative cos u du. So what is u again? E to the 2 theta, and then we add the plus c. So let's begin. What are we doing today? Well,
By the way, who invented calculus? Leibniz or Newton?
that's a good question. You do not ask to the guys on the job. Okay.
That's what people say when they don't know the answer.
What did you just say? Okay. So here we have a u sub. Okay. So our u equals root x. So what are we going to do? Well, how do we differentiate that? Well, that's x to the 1/2. So stupid. Okay, so that means that du is equal to, how do we do the power rule again? Well, we take the exponent, we put it in the front, then we subtract 1. Okay, so we have 1/2 x to the 1/2 minus 1 is negative 1/2. I'm finding this very fun. Then we have dx. Alright, so now what do we do?
You know how many
Well, we want to find
people-
dx
you know how
because
many-
we want to plug in dx over here. So, what do we do? Well, what we do is
You don't let your student talk in the classroom?
we divide over here, and I guess this is 1/2 x to the minus 1/2, but the thing is, when you have a negative exponent on the bottom, then you can bring it up and change it to a positive exponent. So this is 2x to the 1/2, or rather, root x du. Okay, so now let's plug that in. E to the u over root x. Yes, I know this is illegal because we didn't plug in the u over here. Whatever. Times 2 root x du. Cancel, mansel. Okay, so now we just have 2 eu, or we can just put the 2 outside, eu du. The integral of eu, it's just u. Because think about it. What is the derivative of u if we're differentiating with u? Well, it's uno. So we get 2eu or plus c or 2e to the root x. That does not look like a 2. 2e to the root x plus c. Wait, what was the problem
You are
there?
racist against your own father.
And no. I don't want to get canceled. Shut up, for the love of God. Okay. We can relax now. Okay, so, this isn't actually an IBP problem. So I was actually flipping through the Regents book. We have got to pick our UDV. No, actually the Barron's
What
book
number
for
is
AP
it?
Calculus. Says that over here. Now, I was actually flipping through the Barron's book to review the AP Calculus BC concepts. And then, I didn't just see AP Calculus AB, not AP Calculus BC, but I saw an AP Calculus CD. It was one of those CDs that you can put in one of those record players. Makes sense, doesn't it? That's an old-timey thing, though. So, we know that the integral of UDV, the integral of UV, minus the integral of VDU. So we picked our U, and we picked our DV. So, now, let's get to work. What can we do? Well, what is V? How do we take the integral of e to the minus x? Well, the integral of e to the minus x dx, if you think about it, it's just e to the minus x over the derivative of minus x is minus 1. We don't gotta include the plus c right now. We'll include it at the end. So it's minus e to the minus x. So that means we have u x times minus e to the minus x. So minus x e to the minus x minus the integral of, we know v now, it's minus e to the minus x. We can actually cancel these out and make this a plus sign now. And then we get e to the minus x, and what's the derivative of u? Well, it's actually 1 dx. So we'll just put the dx right back on there. So this is our integral. Minus x e to the minus x plus, well, what is this? Well, we already know that the integral of this is minus e to the minus x. Then we gotta add the plus c. Then we get minus e to the minus x times x plus 1 plus c again. Mr. I have 48 brain cells. Probably can't.
Is it bad?
The average human has 100 million, so I think that's pretty bad, buddy.
It's your father.
Hasn't stopped me before. Okay, so this is our u and this is our dv. I'm doing that in camera. We know that the integral of e to the x is the same as e to the x, so that's basically a solved problem. Meanwhile, if u is x squared, then we know that du is just 2x. And let's also add those stupid looking dx symbols. Alright, so now is this? Well, we can use the formula, the integral of u dv is equal to the integral of there's a frog in my mouth today, a French frog.
How the French frog is different than American frog?
Well, you know how I said French people are not people? French frogs are not frogs. What am I even saying? French frogs are aliens from the planet Titan.
When I look at the Macron,
From the moon Titan.
When I look at Macron, he looks like any other human.
Do you think Mark Zuckerberg looks like any other human? Yeah, neither did I. Okay, minus the integral of v du. Alright, so
Who's Mark Zuckerberg?
the founder of Facebook and also hypothetically a lizard monster. Others say just take my word for it because he never blinks. Okay, so x squared ex, right?
What is Facebook?
You're gonna post this on Facebook, idiot.
Oh.
I'm pretty sure you already know what Facebook is, Mr. I have 10 brain cells.
Oh, that was 10?
Yeah, those 38 decayed away while you were talking to me. They were just like, nope, I'm out of here. This one is too dumb. Okay.
It's your father.
Should I care? Do I care anymore? Just ask yourself. Okay. So we have x squared e to the x. What?
You're gonna one day give me heart attack.
Alright, minus, what is this? Well, we gotta int my parts again, my buddy. So, what do we do this time? Well, our dv is gonna be e to the x, and our v is gonna be e to the x, but our u is gonna be 2x, and our du is gonna be 2 dx. And what's good is that our du is a constant. That's how you know you're close to finishing the problem. So, we've got u times v, 2x e to the x, minus the integral of v du. And we can put the 2, which is a constant, outside. So we've just got 2x e to the x minus 2ex dx, or just 2ex. So we're going to add the plus c in the full equation. So now, putting that in, we get minus 2x e to the x plus, because minus and minus makes a plus.
Why minus and minus makes it plus? Isn't it racist?
What?
I don't understand why minus has to be plus.
What?
Isn't it racist?
Oh, I was gonna install the refactor. Oh, no, I'm not gonna do that. Alright. Well, your brain certainly shows us that 2 minuses don't make a plus. Okay, so x squared e to the x minus 2x e to the x plus 2 e to the x. Why are you looking at me like that? Why are you looking at me like that?
I'm thinking, well, minus has to be plus.
Not in your case. Alright, so let's begin. And in fact, my calculus teacher is currently 49, so that's cool.
So you agree that minus...
What did I say? Whoa. I said my calculus teacher was turning 49. I never said the minus make plus. Okay, so today we're going to be doing e to the x plus e to the minus x over e to the x minus e to the minus x. Alright, dx. How do we do this one? Well, u equals e to the x minus e to the minus x. So, du is equal to e to the x, because the derivative of e to the x is just e to the x. Then taking the derivative of this, what's the derivative of minus x? Minus 1. So it does minus e to the minus x. And minus makes a... Oh, wait, I can't say... Shut up!
I saw love.
No one needs to hear your input.
No.
9 brain cells.
I saw love.
No one needs to hear your input. 9 brain cells.
Your father.
I know you said... wait, say... Last time it was 10, though. No one needs to hear you. 9 brain cells.
Last time you said 48.
They all decayed away. They were like, nope, this one's too dumb. That's why I said minus and minus don't always make plus. Okay, so minus and minus, oh wait, that's a trigger word for him. I just can't say it. And so we have dx over here, so dx is du.
Plus times minus is plus. Isn't it racist?
Look, 8 brain cells. Let's put it this way. This is one line.
You just said I have 9 brain cells.
I'm going to teach you like the pundit in the first chapter of Manis. Minus plus minus is?
2 minus.
Yeah. How many lines are in 1 minus?
1 line.
So, that means that 1 line plus 1 line is 2 lines. How many lines are in a plus sign?
4 lines.
Sorry. Let's just not do that. Did it just say 4 lines? Oh no! Oh no! How'd you get out of high school? Oh my god, no. Okay. Oh, let's just do this. Oh god. Over u times du over e to the x was e to the minus x. Cancel, even though you're probably too dumb to understand that. The integral of 1 over u is?
I think overuse of e is also racism.
Just like Twitter. We'll have to take care of him, boys. So, this is just ln of u, but that's ln of e to the x plus e to the minus dad's brain plus c.
Are you racist?
What did I do? Dx minus the integral of 2x dx plus the integral of 3 dx. Alright, so now we can do this. Notice that this is 3 times the integral of x squared dx minus 2 times the integral of x dx plus the integral of 3 dx. Alright, so now how do we do this? Well, we know that we can use the reverse power rule to do this integral of x squared. The reverse power rule says that the integral of x to the n is equal to x to the n plus 1 over n plus 1. So in this case, n is 2. So it's going to be x to the 2 plus 1 over 2 plus 1. So it's x cubed over 3. So we have 3 times x cubed over 3 minus 2 times, we follow the same rule, but remember, there's a hidden 1 tacked on over here. So if we have a 1 there, then integrating it will give us x to the 1 plus 1 over 1 plus 1. This gives us x squared over 2. 2 times x squared over 2 plus 3, and this is technically x to the 0. So doing that same rule over again, x to the 0 plus 1 over 0 plus 1. So that's equal to x. So just 3 times x. And remember, since there was an integral, all we have to do is tack on a plus c. Now, we simply cancel out everything, reduce everything. There's our answer, x cubed minus x squared plus 3x plus c. Now, how do we show that this is actually correct? Well, because the integral is called the antiderivative, then we take the derivative and we should get back our original. Alright, so taking the derivative, we use the power rule. So we take the 3 and we put it in front. So we have 3x squared, and then minus x squared, you do the power rule again, and then you do the power rule one more time, but this is going to be x to the 0 times, no, it's x to the 1, and then that's going to be 1x to the 0. So this is just going to become 3, then plus c is a constant. So constant derivative is 0. Alright, so that does gives us what we originally got, dx. Alright, so now usually we would do a u-sub, but first of all, there's nothing to cancel out here, and second of all, there's only a power of 2, so it's relatively benign to distribute. So we know that a minus b squared is equal to a squared minus 2ab plus b squared. So now that becomes x squared minus 2 times x times 1 over 2x plus 1 over 2x squared. So that's x squared minus, these cancel out and these cancel out, so 1 plus 1 over the whole squared of 2x, so 4x squared. So we are now, and we can actually make it better by making this x squared minus 1 plus 1 over 4, and we bring this up, x to the minus 2. So we get the integral of x squared minus 1 plus 1 over 4x to the minus 2 dx. So now when taking the integral, we now know our simple rules. First of all, the inverse power rule for x squared. You add a 1, divide by 2 plus 1. So you get x cubed over 3 minus, whenever you have a constant and you're integrating it, you tack an x on the end, plus we use the same power rule over here. So this gives us minus 1/4 x to the minus 1, or if you want to not have negative exponents, this is minus 1 over 4x. It's x cubed over 3, and plus c. X cubed over 3 minus x minus 1 over 4x plus c. Now taking the derivative is also a pretty simple process. Taking the derivative of this, the x cubed on top becomes 3x squared via the power rule. So we have 3x squared over 3. Minus x becomes 1, because when you are differentiating a single variable, that variable becomes 1. You just get the coefficient. So minus 1 minus, well, let's see. What is x to the minus 1? Well, that becomes, via the power rule again, this comes down, minus 1x to the minus 2, minus 1 over x squared. So, combine that with the minus 1 over 4 that we had over here, and we get negative 1 over 4x squared. So, we reduce here, x squared minus 1 plus 1 over 4x squared. A squared minus 2ab plus b squared. So taking the square root of x squared, we know that a is x, and then we know that b squared, taking the square root of 1 over 4x squared, is 1 over 2x. And just to test it, minus 2ab is equal to minus x times 1 over 2x times 2, and this cancels out, this cancels out, this cancels out, minus 1. So, we have confirmed that this is simply just x minus 1 over 2x squared.
Integrals. Wow, who's writing these? Must be very bad at English. Sorry, yeah. Okay, so now it's no longer integral, but integral, like how it's supposed to be spelled. Okay, so now, this is our first introduction to U-subbing. Probably heard of it before if you're in calculus, but what is it? Well, just to review, a U-sub is this. Basically, you have a bunch of complicated crap, and then you have this, and then a little bit more complicated crap on the outside, dx, right? Well, here's the thingo bingo. What we're going to do is we're going to take the complicated crap inside, and we call that u. Then the derivative of, then dx is equal to du over the derivative of u. Why? Well, I'll show you. Because u is, well, u, so du is u prime dx. So that means that dx is du over u prime. And then whatever u prime is, it will usually cancel out what is over here. So then you are simply left with the square root, not the square root, it can be anything, but in this case it's a square root, u, and then du. So you can differentiate it like a normal variable now, because you're doing it with respect to something different, u itself. And then, when all is said and done, taking the integral of u to the 1/2, actually I shouldn't be forgetting this, this would be 2/3 u to the 3/2. And then, all you gotta do is unsub the u, and that's it. Alright, so now let's try that strategy here. Now, there is nothing to cancel out outside these little square roots, but what is good is that taking the derivative of this leaves us with a constant. So let's take all this crap in here, call it u, and then we know that du, or dx, is equal to du over u prime, which is going to be the derivative of 4 is 0, and the derivative of t is 1, so minus 2t is going to be a minus 2. So now that simply means that, oh wait, not dx, dt. So now that simply means that this is now the square root of u, and that's times du over minus 2. So we have minus root u over 2 du, and you can treat this like a normal variable now. So, doing all of this, we know that, well, we just showed you this example, that the integral of the square root of u is equal to 2/3 u to the 3/2, right? After inspection, it looks correct. So, now, because remember that we can take constants outside, this is equal to minus 1/2 times the integral of u, so it makes it minus 1/2 times 2/3 of, well, what is this? 4 minus 2t to the 3/2. And now we can actually reduce it, and it becomes minus 1/3 times 4 minus 2t to the 3/2. If you're curious what that really looks like, it looks like this. And just to make it fun, we're going to actually make this 2t minus 4 and this a positive 1/3. That's the answer. Hello everybody, my name is Soborno from Science Lab, and today we are doing integrals. So this is problem number 4, and once again, this topic is u-subbing. Alright, and don't worry, later on it becomes harder and harder. We're going to have to use multiple topics in order to get through these. So, oh yeah, and by the way, these are all indefinite integrals, so they have no bounds. And can you believe it? We're going to do 80 of these, which means we're only 0.05%, or rather 5% of the way through. Alright, enough about that blabber. What's the problem? Well, it's the integral of 2 minus 3x to the 5th power dx. Alright, so how do we do this? Well, you would not want to go through the hell that is distributing all of this crap. So instead, what we do is a little something called u-subbing. So what we do is we have this thing u, and we're going to treat it like a variable. But it can be a polynomial or a trigonometric function, etc. So, in this case, our u is going to be 2 minus 3x. We're going to treat this like a variable. Now, what is the derivative of this? Well, du is equal to the derivative of
constants is 0, and then since this is x to the 1, you take it away. So this just becomes -3. Oh yeah, and you have to add a dx at the end. Now the thing is, do you see the similarities here? Yeah, I do too. So, let's try this. dx is du over -3. And now, what we can do is, now we take this and we divide by -3. We get dx equals du over -3. Wow. So now we can take this and plug it in here. And the thing is, since we're differentiating with respect to u, we can treat u, which is 2 minus 3x, as a variable. So now, let's plug that in. So this is the integral of u to the 5th power du. And now, it becomes simple by using the reverse power rule. And if you also forgot that, it says that the integral of x to the n dx is equal to x to the n plus 1 over n plus 1. Hopefully you can see this reasoning because the power rule is simply the opposite of this. So if we put nx plus 1 over n plus 1 over here, then that gives us, we subtract 1 from the power, n, and then we bring that power over. And then we bring that n plus 1 over here. So hopefully you can see how everything cancels out. Alright, enough about that jibber jabber. Now, we have x to the n plus 1 over n plus 1. The power is 5, so it's u to the 5 plus 1 over 5 plus 1 plus c. That's it. Thank you everybody for watching. Oh, wait. Oopsie daisies. I forgot to sub it back in. U is 2 minus 3x to the 6th power over 6 plus c. Do you see just how powerful U subbing is now? 44, so let's just write it in the way that a normal person would. Okay, so what is 44 known for? Well,
44 fingers.
44 is a palindrome because if you write it backwards, it's still the same.
I know some people with 44 fingers.
Why? Okay. 44 is a rep digit. What that means is that it's simply one digit written multiple times. 44 is also part of the Fibonacci sequence.
Fibonacci?
No, Fibonacci. Instead of Fibonacci being the sum of the last two numbers, Fibonacci is the sum of the last three numbers. There's also Petronacci, but that's just weird. So 0, 0, 1, the sum of those is 1, the sum of those is 2, the sum of those is 4, the sum of those is 7, the sum of those are 13, the sum of those, 11 and 13, are 24, then the sum of 7 plus 13 plus 24 is 44. That's pretty cool, ain't it? Alright. So what is 44 anyways? Well, we have the integral of cos x, or rather cos theta as it's written, times e to the sine theta, d theta.
How are you supposed to say cos or cosine?
Okay, so how would we do this? Well, it's pretty obvious that some U-subbing needs to go on here because you can't really integrate this right over here. So what can we do? Well, let's take this part and U-sub it. So let's say our U was sine theta. And now you can see how this works out because cosine theta is simply the derivative of sine theta, and we're going to be dividing by the derivative of sine theta. So d theta is equal to du over sine theta will become cosine theta because that's the derivative of sine theta. So now we have cosine theta times e. U is sine theta, so we could write this as e to the u. Then d theta is du over cos theta. So now we simply get e to the u du, and now integrating as if u were the variable, we simply get eu plus c. And now unsubbing, we get e sine theta plus c.